Welcome to today's Datavail webinar, and thank you for attending. Today's webinar is titled Informatica Health Checks, and we are excited to have Chuck Ezell presenting, Datavail's Vice President and Practice Leader of Data Integration Services. Chuck, I'll go ahead and turn it over to you.
Thank you, Jane. So, Informatica Health Checks. There are a lot of things to look at when we start talking about health checks in general. But then when we add the complexity of an ETL tool like Informatica, there's even more to consider. So I'm hoping as we step through different things today, we can identify some issues, potential bottlenecks, potential details that maybe we might even uncover some things you haven't thought about. Perhaps there is something today that you'll glean from the presentation, and I hope you will. We're going to go step through just very quick couple of slides on who Datavail is, so you guys understand who we are, and just in case there are details perhaps that you might not have heard or don't know. And then I want to jump right into the health checks, talk about what our mindset is around health checks. Where do we start? What are the things that we address? What are some things that we've seen in other health checks? And then really look at the Informatica application, the configuration, some settings, logs, monitoring tools. And then I want to spend just a few minutes talking about some performance tuning things that we found in some of the health checks that we've done with Informatica and in ETLs in general. And then we'll just do some quick closing comments. So a little bit about Datavail. We've been in business for 13 plus years. And our core business is database operations. We support all of the major database platforms from SQL Server to Oracle to DB2, all the way out to MySQL, Postgres, Mongo. And we have 24/7 services. So you can come to Datavail and we can provide the US and global services around supporting operationally all of your databases, from everyday mundane tasks to backups, patching, upgrades, to more complicated things like projects and full implementations of moving from a on-premise out to the cloud, whether it's Oracle Cloud or AWS or Azure. And we also handle analytics, visualization, integration projects. We do Microsoft Analytics, we do OBIE, and of course, when you're talking about data warehousing, analytics, you've got to have integration tools like Informatica, OBIE, SSIS, Talon. There are all kinds of Pentaho, all kinds of tools that we use to bring that data in, transform that data, but also visualization from OBIE to Power BI. All kinds of tools that we support, and we do a lot of projects around that. 300 plus customers that we have and we support from that perspective, and our average customer stays with us 7 years. We also do application support, EBS, Hyperion, SharePoint. We do ServiceNow customizations. If you come to Datavail and if you're working with us, you're familiar with ServiceNow. It is our ticketing system. It's the way we manage all of our intake, all of our tracking of our tools, our changes. It is our engine that we run our business off of, and we have done a lot of our own integration between our system and other customer system, ticketing across other Remedy and other tools. We integrate into ServiceNow. So we do it for ourselves, and we've done it for others as well. Custom development, .NET, Java, ADF, Apex. So just a little bit of an idea of a landscape, really, of the kind of things we do, who we are, and we don't necessarily focus on specifically any one vertical. We touch so many different companies that are in many, many different market segments, many different industries. And so the interesting thing that we find is that there are multiple ways for people to implement Oracle, many, many different ways to implement SQL Server, to implement DB2 or Informatica across systems like that. So as we look at all of these different systems, we see all of these unique implementations, all of these unique problems, all of these things that we support 24/7 issues that we deal with. So hopefully that gives you a sense of who we are and maybe a broad stroke on the kind of customers that we support across all kinds of different industries, all kinds of different systems, different implementations. So when we start thinking about health checks, you know, for us, we have a certain mindset where we want to be as thorough as we can. We certainly want to be able to collect all of the details. We want to, you know, look at not just the database, but any other peripheral piece that might attach to it, and it gives you a much more comprehensive view of the database and all of the other tools potentially that touch it. And looking at the data itself, where the data lives, how healthy is that data? Looking, you know, kind of thinking more specifically about Informatica. When we have these workflows, these ETLs that we've built, there are unique touch points for each ETL, for each Informatica workflow. And there are problems that can occur when we don't manage our data, when we don't really pay attention to the storage speed or the infrastructure where the system is running. So we want to be proactive. We want to be proactive, and that's really kind of the mindset or the approach or really the intent in doing a health check. How often do we do health checks? If we do a certain set of health checks every day, then we can be proactive about how we think around about the issues and problems going on with our workflows, with our ETLs, and we can take a larger or broader group of metrics and checks that we do from a monthly standpoint, from a weekly standpoint. You know, so there are purposes and intents for looking at certain things on certain frequencies. And again, the goal is to be proactive and think a little bit about where are we going, what are we trying to monitor, and it's, you know, it's not just a one-time thing we do every 2 or 3 years when we begin to have problems. We should be setting ourselves up so that we're doing daily health checks, monthly and weekly health checks. So let's talk a little bit about where to start. And for us, when we think about health checks, you know, we start with a database. Really starting from the bottom up gives us or puts us on the right path to getting a more thorough, comprehensive view. The more granular we can start, the better we have a greater sense of what the roll-up looks like. We take all of these details many times and we roll these up into the bigger, broader decisions. So a good health check is going to start with the data. And start with the database, the data, where the data lives, especially if we're talking about something like an Informatica workflow. The database is a critical component of our Informatica workflows. And so when we talk about Informatica health checks, the database is a great place to start. There are source databases. There's a repository of all of the information for Informatica. There's a target system where we're loading data in, and sometimes there are even special databases set aside for staging and transformation. So the database is a critical component. We want to take the proper proactive approach in taking a look at these things. Now, I've been at Datavail for about 7 years, and after the first couple of years being at Datavail, I realized that there were a good number of issues we began to run into on a regular basis. And one of the things I also found in touching so many different environments within the first couple of years was that there wasn't really a standard approach. All of the senior guys we worked with, all the folks that we touched, you know, spoke to, they all had kind of their own mindset or their own thinking about where do we start? When we have a problem, what are the first things we look at? You know, some more successful than others. And so I started thinking that there has to be a better way for us, a better approach that can be consistent, a checklist, if you will, of sorts, that really kind of gives you a starting point when you have a major issue, whether it's a firefighting situation when you're having to be reactive, or really from a proactive standpoint. So this 5S approach is what I came up with, and thinking about how we approach situations when we have performance problems around the database. There's a certain process that you can follow, and in stepping through this in these 5 steps can lead you to some quick wins, quick decisions, and this is not comprehensive, certainly not comprehensive. And those of you that are listening to the webinar and on today, you might see this and you kind of might think, well, it's certainly something that you do every day. It's not something you would think about, but really, if you start with the SQL code and you think about if you think about why we're running the SQL code, what is its intent? What are we trying to achieve? And we're running this query because we're asking the database for a certain data set, and that query can be highly complicated. It could be thousands of lines. It could be 200 lines. It might not be too terribly complicated. It might have 2 table joins. It might have 20 and multiple unions and merges. So the code itself is an interesting, and I think the first place that I usually go when I begin to see problems in the database. So as we're doing health checks, the first place we ought to be thinking is, well, let's take a look. There's no way you can look at every piece of code, but there is a way you can pull the top 10 queries. You can pull the top 2 or top 5 underperforming workflows. You can go to your logs, grab that SQL. You can run the explain plans. If you run the plan and you look at it, you go, okay, the plan looks fine. Or perhaps the query is taking a long time to run, but you're doing everything right. Then maybe it's the statistics. Maybe it's the stats. You talk about stats as like a cheat sheet, right? If you have a cheat sheet and you're asking the database to return a data set, you've given it a query, it's going to return a data set. Instead of going to the table and trying to do counts on all the rows and trying to make decisions about which tables it should join first and how it should create its execution plan, it's going to look at the cheat sheet and it's going to make decisions. And if we are not updating our stats, that cheat sheet will be wrong. There'll be errors, the row counts won't be right, or it'll be off just enough that the plan that's produced by the optimizer engine or the execution engine is going to come up with something that probably could be a poor execution plan. It might skip indexes. It might not even see certain indexes. It might choose to do some strange thing. So the stats are a good place to go if the SQL code seems to be performing well. The segmentation would be the next place. And really, to me, when we think about segmentation, we're talking about space, how much temp space, how much storage space are we using global temp tables, but also indexing, fragmentation, segmentation, how the data is structured at the block level, not talking about data models, but talking about data stored in a table. How is it structured? Do we have fragmentation? Are we using indexes properly? Should we not be using indexes on these queries? Do we have the proper indexes against the right columns? Questions like that should be answered. And then, of course, you've got other peripheral things that happen that consume resources on your system. Sessions. There could be all kinds of things going on with the sessions. There could be people running queries against the database that, maybe they're running an ad hoc query against production, not realizing that they thought they were connected to dev, or there could be a query running against a report that they only run once a month, once a year, and it's causing a performance problem that then affects the batch load process. Maybe it's a month end. Kind of thinking about month end, you've kind of got these scheduled processes, right? There is a job for most of our databases that will rebuild indexes or defragment tables or run an ETL. Maybe we're running multiple ETLs against our source system or our target system, and we have overlapping processes, and we've created an issue of contention. So things to look at, and this 5S approach, I'm going to sort of apply it to several different things as we go through. But just kind of jumping on kind of stepping back a little bit and kind of thinking in broader terms, when we do health checks, we need to be thinking about some other things too, especially when we're talking about ETLs and Informatica, the data models, the organization of the structure of the data itself. Not necessarily now thinking as much about the segmentation at the block level, but really our table structures and our data modeling. I mean, when we're trying to query against these tables, have we normalized out to the third normal form, and it's too much. There's too much normalization, which can be a problem. Sometimes too much normalization can kill us. You know, so there's a nice balance we have to strike when we talk about normalization. But you know, maybe we need fact and dimension structures instead of a relational structure, like a typical OLTP type CRM, EBS, financial system. So, you know, kind of thinking about our data models and our structures. And if we've migrated from one platform to another, this is a consideration we ought to take a look at. Were you previously on Oracle and you've moved to Postgres? Were you previously on SQL Server and you've moved to Oracle or Netezza? I mean, right now we're helping a customer implement a new Netezza, a full rack, and they had a half rack, and you know, they had done like this lift and shift from SQL Server right into Netezza, and they get performance because the Netezza appliance itself is going to be really fast. But the structures, the indexing, the data models, all of these things were conceptualized and built around SQL Server capabilities. So then when you lift and shift into a Netezza environment, your indexing concepts, your data structures, your data models, all of these things can be sort of really misguided and there needs to be a different approach. And so we're now re-indexing certain columns using the Netezza mindset as opposed to SQL Server. So we need to make sure that what we're running is optimized for the current database, that we're not running ANSI SQL functions, for example, when we could be using T-SQL or PL-SQL or PGPL SQL functions that are really part and parcel of the product platform itself. I mentioned data fragmentation. It's important for us to look at this when we're doing health checks for Informatica, because data fragmentation can affect clustering factor of the indexes themselves. If data is poorly scattered across a disk, you know, you're going to have a slower performance with your reads, slower performance with your writes. It's going to take longer for you to update and rebuild your indexes. Your statistics will be affected. I mentioned clustering factor. All of these things will tie into data that's fragmented, not to mention the fact that you could be using space that's really, once you begin to defragment, you're going to recover all kinds of other space. For some people, data defragging is sort of a way to recover space, and that's kind of their mindset. But to me, I think it can be a big benefit for performance. So we will actually look at fragmented tables on very large tables that are highly fragmented, and make sure that those are defragged on a regular basis. We actually, as a part of our weekly health checks, we'll look for these things and have weekly scheduled times where we defrag tables. Our indexing strategy is really important. I've kind of mentioned a little bit about that, but I'll touch on one point. There are times when Informatica, when it runs, all the SQL is generated at execution time. So at runtime, you've got all this new SQL, and sometimes you probably noticed this before. You created an index, but it wasn't picked up, right? There can be times when our stats are not updated, our data fragmentation is not the data is scattered such that when we create an index, the clustering factor on the index is so poor that it's ignored by the execution engine or for some other reason. But we want to make sure that we have the right indexes, and there are times, and we're going to touch on this very quickly in a later part of this presentation, but there are times when indexes can really hurt us, and we want to make sure that we have the right ones, that they're properly structured. Partitioning, when we talk about Informatica workflows, many times we're pushing and transforming millions of rows in the evening. We're, during batch runs, we're running all kinds of transformations on a lot of data. So as we're doing this, we want to make sure that we have the right partitioning. The partitioning helps us when we're doing all kinds of large queries and everything else. So partitioning strategy is really important, and that's something we should be looking at when we're doing health checks. Are we using partitioning properly, or have we even considered it? Perhaps we have not even considered partitioning, and there are ways for us to do this within Informatica from our query sets, and just kind of thinking of it from a governance perspective, but also from the database perspective, using the features we have in our database platforms. Proper session connections, we want to make sure that we don't have too many connections trying to get to the database all at the same time, and make sure that we have the proper settings, not only for the application, but whatever our hardware can support. And that might be more important, to make sure that our hardware can support the number of transactions and the number of sessions we're trying to connect and run and thread all at the same time. And then kind of the same concept here from a operations standpoint, parallelism. There are times when we want to make sure we're making use of it, and other times when we want to be careful that we might have tried to implement too much parallelism. And there are times when we're trying to do too much and it's causing our bandwidth to be consumed and reduced to the point where it's not usable. So let's touch on some source, transformation, and target issues. And so when we think about Informatica, when we think about workflows, we think about an extract, a transform, and a load process, right? So there are different things that we need to be looking for in each phase of an ETL that come into play, especially when we're doing a health check. So just kind of focusing on the source issues and ideas. A lot of times the source for a traditional ETL are source systems or our OLTP or our transaction type databases. I mentioned them before, like a ERP system or CRM system, a very relational, traditional structure that we think about. And the benefit here is that all of the things that we know about a traditional tuning approach, it's going to apply. Our indexing strategies, our typical mindset around tuning, OLTP, CRM systems, or ERP systems, those are going to apply when we deal with source issues and different problems that we might face. So thinking about some of those. Poor plans, right? We want to tune in the traditional fashion. And again, maybe bringing in this 5S approach. We could be looking at the SQL code. Maybe there's a better way to filter the data down. And what I mean is, when we're selecting against millions of rows, the sooner you can reduce that row set in the process of querying that data or building your query, the better the execution, the better the explain plan, the better execution at the database level you're going to get. So what I mean is, add your filters, your where clauses in such a way that it reduces the row sets more quickly within the query itself. And you set those priorities, you can use this better filtering to improve the response time of reads and your select statements, for example. Again, I think we've mentioned this, using custom, instead of using ANSI SQL, use the vendor functions. Use the functions that are specific to the product platform that you're on. And looking at the stats, right? Looking at the indexing, table fragmentation, those are really important. Now, I think too, this is to me where when we talk about sessions and processes that can conflict or compete with resources, when we talk about source issues like this, I think especially on our extraction phase of the ETL, any type of contention or processes running, if I'm trying to extract data from an AX system in the evening, and let's say finance is running their batch jobs to process new GL data, well, their processes are probably touching the same tables that I'm trying to pull from. And our Informatica ETLs run every night against AX, but for some reason, today, this time, they're slower. Well, they're probably slower because there's contention between those tables. They're writing, we're trying to read, there's updates that are trying to happen, you know, so those types of processes that are scheduled, we want to be looking for. And when we do health checks, a lot of times we will actually schedule things out, or we'll build out an Excel spreadsheet of the schedule of what's running when, so that when we're monitoring during the health check, we can actually see some of those processes, and we know what's going to happen, and then we can kind of move some things around in the schedule and a process. Or if you can't move things, one of the solutions that we've come up with for some of our customers is replicating data off. And in the same type of way that you think about replicating data into another database for reporting, think about replicating data out to another database for ETL or extraction. There's, you know, only so much data that we really are interested in. If there are thousands of tables in EBS, we might really only be interested in 200 of those tables. And what we've done is we've extracted those 200 tables and their stats from the production source system, replicated those to a separate database, and then we run our Informatica ETLs against that. So just some different source issues and things that we've discovered, some solutions that we come up with, and some things that might come up with when you're doing a health check. What about the transformation stage? Kind of thinking about all of the staging problems and other issues, depending on what things you're trying to do in your Informatica ETL. When you do a health check, you want to look for things like the memory on the server where you're doing your transformations. Could be on the same server where you're doing your extractions, but the memory and the temp space are critical. We want to make sure that that has plenty of available space so that our workflows don't fail, so that our merges and all of our calculations, all of these things can happen much faster. Some of the other things that we've seen in transformation stages where people have actually tried to use file system lookups, where they have a CSV file to look up against, or they have a text file that they're pulling into Informatica to kind of do some quick lookups and everything. Convert that stuff into a table in the database, and you can manage it better. It's a lot faster that way, and we found that that really helps. So in doing some health checks, we've come across problems like that. And again, you can take the 5S approach, look at the SQL code, look at the memory merges, right? In the transformation stage, look at the things that could consume the most memory. Look at those joins, look at those merges, look at the calculations, the coalescing, all of the things that could potentially consume memory or cause CPU consumption. Stats, indexing, all of these things can hinder the performance of our transformations. And if we don't have enough, if we don't have the proper temporary space, we can have failures. We should be looking at our logs. We should be looking at other things. If you have something product specific like Oracle ASM, you know, make sure that you have plenty of headroom in that storage configured so that it can grow and shrink as it needs to. And as I mentioned, the file system lookups perform better. So kind of shifting to the target issues, we've talked a little bit about things you have seen and things you should be looking for in your extraction, things you should be looking for in your transformation staging area. And then when you're doing your writes, something that's really important, and it seems like it's obvious, but a lot of times we don't think about it, but your write speeds, when you're doing loading, loading is writing, and write speeds, I/O on the target system is critical. Dropping indexes on the tables where you need to write the data, really important stuff. Stats, you don't need that stuff while you're loading the data. A lot of times we're doing full refreshes on tables where, you know, sometimes we do incrementals, right? Sometimes we do full refreshes. If you're doing a full refresh, drop the indexes, drop the statistics, do the load, refresh the table, add your indexes, add your stats, you know, do your rebuilds and everything afterwards so that it's accurately reflecting what's then in the table. And again, here's the 5S approach. You can take this from go ahead and use the approach to mitigate potential problems. We know that inserts can be slow at times, depending on how much data we're trying to insert. You can use bulk loading. You can make sure that there are other features within your product, like I'm mentioning Oracle here. You can use the append or append values. There are all kinds of things you can do from a certain product-specific approach. You can add parallelism, right? There are ways for you to add inserts and updates in parallel. And one of the things we actually did in Informatica on a very slow workflow was to take some very slow serial inserts. We converted that into multiple staging. So we looked at the total number of rows and we divided it by, I think we did 25. So we divided it by 25. So there would be groups of 25 writes. And those 25 writes did bulk inserts. So those 25 selects would do basically a bulk insert of thousands or millions of rows at a time. And we've reduced a 5 or 6 hour load down to about a 1.5 to 2 hour load. So you can do things like that within Informatica. It's very powerful, as you probably already know. So kind of stepping through these three ETL, extract, transform, load areas when we're kind of doing our health checks. If we think about looking at our health checks and our environment from that perspective, it allows us to focus. It allows us to kind of think about specific things that are categorized properly. So we've kind of talked a lot about the database. I want to touch on the application and talk a little bit about Informatica, review some settings. I want to talk to you a little bit about some monitoring tools that I think are really important, some things that I use, some things that our developers use, and a way to think about logs and managing temp space. I mean, we've got to be looking at our source, stage, and targets, and talk a little bit about some of the hardware. So at a very high level, when we think about the architecture and the application itself, we have an interesting mixture. With Informatica, we have a nice sort of commingling of file system features, and we have application setting features, and we have a repository that has a lot of information in it. That it houses all of the details, all the settings, all of the workflows that you've created. I mean, there's a lot of interesting stuff here. So when we think about Informatica from an application standpoint, and we're doing health checks, we want to look at it as comprehensively as we can. So thinking a little bit about the hardware, again, the I/O, the throughput of both the file system, the reads and writes at the disk level of the OS, as well as the database is important. And, you know, I think it goes without saying that the memory and the CPU is really important. We have to also pay attention to the number of processes that are running. Are you running Informatica, the application itself? Are you running that on a system that already has multiple other processes going on? If you are, then that could be creating all kinds of other competing resource consuming processes going on that can be affecting your performance. Network performance is also really critical, right? Looking at all the interconnects between the database and the file systems and all the other servers, we want to make sure that we have the proper the interconnects and our network speeds are adequate, ideally as fast as possible. And then just kind of jumping over to some of the other things that I think are really important when we start looking at our processes and what we're monitoring and doing health checks around Informatica. Depending on what database system you're on, this applies even more so. Java JVMs, the garbage collection, the memory, the I/O configuration, your pool settings, settings on huge pages and large pages, all this stuff's really important. So what I want to do is I want to step you through the execution process, and I want to kind of use this as an example to kind of explain when a user executes a workflow, what are all the peripheral things that happen. So when we start a workflow, the Informatica integration service, it actually begins to execute the workflow, and what it does is it goes to the repository, which is a database, and it will extract or it will select all of the information critical to that workflow. So let me stop there and just kind of, let's drill down a little bit here. So we've just asked Informatica to start a workflow. It's now had to leave probably just kind of making some assumptions about how your system is configured. It's probably had to, across the network, read the Informatica server. The application is making requests to the database. Their database has to be fast enough to respond quickly with all the workflow information that it needs in the repository itself, pulling that data out, responding back to begin to execute the workflow. And as that integration service starts, the workflow begins to execute. It begins to run all the processes, the extraction from the source, all again, we kind of go back to the previous slide. We talked about all of those other peripheral things begin to kind of come into play with extracting from a source. We can think about the 5S approach, the SQL code, all of the things that are going on there. And as this workflow is executed, we have all of this activity going on across the network, right? Once the execution is done, then again, Informatica, the integration service, goes back and it does an update. Hey, were we successful? Did we fail? Did somebody actually abort the system, the workflow because it was running too long for whatever reason? All of that status is updated, and then a log is written. Again, a file system log is written somewhere, and depending on where you have your system, and how your system is configured, it's going to write to a file system across the network. Again, so all of the components we've mentioned, if we are just doing health checks for Informatica against our database, against the data warehouse, for example, think about all the things that we've missed. We've skipped all the hardware. We've skipped all of the other things that something like PowerCenter, a great tool that gives us insight into our workflows. This tool hasn't exposed any of these things. So how do we see then, how do we monitor ETLs and actually see what's going on? I want to step you through some tools very quickly, kind of show you some things that I use to do some monitoring during our health checks and even during ETL runs. There are times when we're not necessarily doing a health check. It might just be a batch run at night and we want to monitor the ETLs. I want to show you just a couple of tools that are things that we use that give you deeper insight into what's going on in the database, what's going on in the logging system and file system and the servers and your CPU and write speeds. But kind of thinking more broadly here, we've got tools, all these great tools we can pull information, we can monitor with, we can create our reports, but how valuable are our reports? What are we doing with these reports? And I wanted to kind of touch on this just a minute while I'm on this slide. When we run our health check reports, we do run database reports. We run file system reports. And we're looking at different things, drive settings, and we want to make sure things haven't changed. We want to make sure things have stayed status quo. But we also are looking for problems that begin to occur as we have data growth. As you get more data, you're going to eventually have problems. Your plans will change in the database. The indexes, even though you have a great indexing strategy today, as the data changes, as the new workflows are introduced, your plans will change. Your indexing strategy will have to change. It needs to change. Your partitioning strategy, it has to change. So we want to be looking at these things on a regular basis. And one of the things that we've done for our customers for Informatica, and it's very easy to do, and you can do this too, you can take the queries that you use every day to pull out the top 5, top 10 underperforming SQL statements, or the workflows that are running poorly. And we've created emails that are reports that we can look at every day. And whether they come across as email, whether we actually store that in a table and we just pull the report when we need to ad hoc, we use these reports, our daily reports and our monthly reports, to generate task lists for our developers. So in the morning when you come in, you can get your report, you can see that of the 10 workflows that underperformed last night, I'm going to give the first 2 to developer A, and then I'm going to give the other 2 to developer B, and I'm going to have them work on those, and that's on their task list for the week. And what it does is it gives us a way to work proactively. We're not, at that point, reacting to problems. We're then planning ahead. We're looking at everything every day and making sure that we're working in a proactive fashion. So, you know, trying to answer the question, how are things running today? How did it go last night? And we're not doing this in a wild, erratic fashion. There's an organization to it. There's a methodology. There's a checklist. So this is what we get when we begin to establish processes and other checklists around things like our health checks. We take our health checks from something we do every year or every 5 years, and we turn it into something we do every day. And it becomes far more beneficial. So let's jump right in to some of the other tools and diagnostic things that we do. I promised a little bit of technical stuff here. So we use the DF-GH. If you use DF to check your drive speeds, you can extract all kinds of really cool information. You can find out your cache reads and your buffer reads. So again, this is one thing that we do. If you're on a Unix, Linux variant, you're going to have DF or you're going to have some similar tool. And the point here is drive speeds, your reads, your writes. If you have SAN storage where your data warehouse lives, or you have SAN storage where your Informatica repository lives, how fast is that SAN storage? How fast and how capable is it? That's the question. You need to be looking at that. So as in part of a health check would be something you'd want to look at. So Power Center, you guys have seen this view. My point here is if you are not looking at Power Center every day, I would encourage you to begin to pull it up, take a look at the workflow monitor, and look at these ETLs. Look at the workflows and look and see. I mean, I can see one here. Out of all, relatively speaking, out of all the workflows, the one that's highlighted there in the middle that took about 15 minutes to run. Now, why did it run 15 minutes? 15 minutes is maybe in this particular context seems long. 15 minutes, in my opinion, is not that long, right? I mean, I know that we all have ETLs that run within hours. And this one, just kind of thinking of it in a relative sense, why did it run 15 minutes? I mean, this is the kind of thing we should be looking at. Power Center gives us this information, but what it doesn't give is it doesn't tell us why it ran for 15 minutes. What was it a database problem? Was it a network issue? Was this problem related to perhaps the repository being slow? I mean, I don't know. We don't have this information, and that's not what Power Center is designed to do, clearly. But we have other tools that we can pull, we can use, and here's an example of Oracle SQL Developer. This product is free if you're monitoring Oracle, or you can connect to Oracle. You can actually use this tool. It's free. You can connect to MySQL. You can connect to SQL Server. I think you can connect to Postgres. You can connect to other databases with it. But again, the point here is SQL Developer gives you a way to actually connect and monitor sessions. So when we are running Informatica workflows, a lot of times I will connect to multiple databases and I will monitor the sessions. And in this particular case, you can see I've selected the SQL ID at the top, line 5, and it's just a read. It's a select statement running against this Informatica production system, and I'm monitoring this at some time during one evening. And at the bottom, I'm getting my explain plans. I can get the weights, the server, the client, the application, any contention or long operations that are going on. It gives me some great insight. Again, this is the kind of thing that you can do during an ETL when it's running. And when you grab this information, I can then see that this particular statement is doing 3 full table joins, 3 full table reads. So I'm looking at this. These don't look 32,000 rows, that's not too bad. But the point here is it gives you some great insight. So you can go up to tools, monitor sessions, and get some great information on what's happening in the database at the time. If you're not familiar with Top, you've got to be familiar with Top. If you're in Windows, PuTTY is the tool, SSH would be the tool if you're in Linux, but Top's going to give you all kinds of great process information and give you your CPU and other great details. But a lot of times this is not enough, right? We've got our database activity, we've got our threading, processing CPU times here, and then I'll also combine that with another tool called DB Time Monitor. And this is a free tool. You can go to DominicGiles.com. I don't know Dominic. This is a product that he built and he maintains. And there's I think he has 4 different types of products. It's a Java-based product and it's very easy to configure. You can see in this particular case, I'm connecting to an EBS host. This is our source system. I'm connecting to the OBIEE database, where the OBIEE repository is, and then just monitoring the DAC. And so I can look at 3 databases simultaneously in one view, and you can actually add 5 or 6 more. Sometimes I'll configure this for every database in the environment that I need to and get that great information. And there's another product here just at the bottom that gives me my wait events. So again, I can set this up to monitor multiple databases. And so what I will do when we're running our health checks, or maybe in an evening when we're actually doing some performance tuning, I'll have Dominic's tools scattered across the screen. I'll have Top running. I'll have SQL Server Management Studio if I'm connecting to SQL Server. I'll have the Netezza tool if I'm connecting to Netezza, or if I'm connecting to Oracle, I've got everything running right there. PG admin, whatever I need, and it's all running, and I can do screenshots. And I will actually do a screenshot and get every tool so that I can see everything and timestamp it so that I can go back and kind of see what happened at what time during that scheduled run, because it's hard to see a lot of stuff at once, but because there's a lot of detail here. But anyway, those are some tools that we use. I think they're powerful tools. And when we talk about performance tuning, we have about 10 minutes and I have about another 12 slides to go, so I'm going to be real quick. Performance tuning around ETLs, we want all our ETLs to be fast. We don't want them to go hour upon hour. But a lot of times we don't think about the fact that we want them to be consistent too. So we want our ETLs to be fast, but we want them to be fast every day for every month of the year. We don't want to have to come in on Wednesday and the ETL ran super fast and then come in on Friday and it failed, or it was successful, but for some reason it ran slowly. There are reasons for us to do performance tuning beyond just breakage, beyond just other issues. We want to performance tune to consistency. So there are things that we can look at. We can look at our network speeds. We can look at our threading and begin to do memory debugging and other things. And then I'm going to probably spend more time looking at the log review here. But with Informatica, when we do Informatica health checks, we need to be looking at these logs. And I'm working towards getting us there in this presentation, but kind of looking at what are the things we need to look at? What are the things we need to think about? What are the trends that occur in the logs that would help us kind of gain a little insight into our operations? But when we think about network latency, I mentioned a few in the previous slide, but iPerf is one we use, and it's real easy to set up. You can use it Windows and Linux. And you basically install it on server A, server B, and it copies a file from one side to the other and physically measures the write speed or the read speed back and forth. And it will tell you how quick your how quick your network connection is between the two. So iPerf is a great one to check your networking speed. For Java, there's a great tool called JMap that gives you some really powerful insight into memory. And if you look at the pink right here, this JMap-heap, and I've got this number 3439. That 3439 is the process ID. So what I've done is I've SSH'd into a Linux server. I've looked at the processes running, and I've selected the Java process that I'm most interested in. And then I run jmap and pass in the process ID, 3439. And I'm adding the argument -heap. And what it does is it gives you this heap size, and it attaches to the process, and it captures all of this really interesting stuff out of the JVM. So this virtual machine gives you, you have certain settings for JVMs for your memory, and it has garbage collection and all this other activity going on. Well, how do you know how well that JVM is performing? How do you know how well the JVM is using the memory? Using jmap will give you that heap size and that configuration and those details. You can see here it gives you your free ratio, actually how big the size is, your perm size, and then other heap usage, your even space, your young generation, and other details that are critical to understanding the memory usage of the JVM itself. But what about the threads? So JVM is essentially a machine, and it's a virtual machine that's running, and within that JVM, you're going to have, just like you do in your Linux environment, every operation is a process. Every process has a process ID. Within your JVM, same concept. You've got threads that are running within that JVM, and every thread has its own lightweight process ID. And so with that lightweight process ID, you can find out all kinds of interesting stuff. But how do you know what's running in the JVM? JStack will give you that thread stack. So you can do the same thing with jmap that I did with JStack, or JStack that I did with jmap. You can pass in the 3439 process ID and get the output of the stacks. This is just a condensed view, just a small screenshot of what you might get from running JStack. And if you notice in the pink here, I'm using a -L. There's a lowercase l, JStack -L 3439. And the interesting thing is when you use -L, it gives you the locked threads. So sometimes we have things that happen within a JVM that locks up. Sometimes the performance locks up, or the performance becomes slow. We don't know why. Run JStack -L with the process ID and see if there are any locked threads. That could be a problem. So indexing strategies. There are a lot of different ways to address problems when you're looking at your plans and looking at the database itself. So some of the performance tuning things that we've done is, in the first example here, we've got this first grid, and this shows us multiple plan hashes. This is an example of multiple iterations and multiple execution plans for a single SQL statement. And over time, that SQL statement has changed. The execution engine, this is Oracle, so the Oracle Optimizer has decided to create different execution plans for some reason, and we don't know why. But as we take a look at that and maybe dig down deep into the SQL, I began looking at the actual indexes. And if you look at the chart below, this little report, you can see that there are certain tables. There are the indexes for those tables. And you notice the number of rows. There's one table that should jump out at you. This PS Journal Lane, if you look at this table, it has this table right here has a very large number of rows. This is a big table. Not too big for Oracle, but it's a large table. But notice the number of blocks. You notice the number of blocks, how big the indexes are. Got to be that big. The indexes are going to be big on a big table. But if you notice the number of blocks that it's consuming, and then you come all the way over here to the clustering factor. To me, the clustering factor of an index is a great indicator of the quality of the table itself. This problem here is that this particular table it ended up being highly fragmented. The blocks that it was using and consuming weren't just due to the number of rows. It was scattered, and that scattered structure, it was because of its fragmentation, the clustering factor ended up being very high. Once we did a rebuild on that table, we did what I call a two-step move, where we copy it out and then copy it back in. You get a copy it out of the table space, copy it back into the table space. You get this really nice cleaned up view. You reclaim unused space, and your clustering factor gets reduced. So a lot of times when our indexes are skipped, there are times I've seen that it has to do with the clustering factor. And what it does, the database sometimes will choose one index over another based on the columns that are in the index. And you'll get something like a skip scan, right? So what's a skip scan? Well, a skip scan is something where there are particular columns in the database that are defined, and we know, and here's an example of a skip scan, and there are columns in this query that it is selected against in this filter, and it's only really using these two columns. But the interesting thing is, what is this skip scan? It's actually in the particular index that it used. This was the index. You take a look at that, what came out, this particular index here, it actually had, the index was indexed across this column, HJob, IType, and UPostDate. And what's happening is the database is skipping over this column to match against that one and this one. Problem is, as it skips over this, you're creating that problem against every single row. And so what we ended up doing to resolve this problem was we created a new index for just these two columns, renamed it, and then we got our performance back. So, you know, these types of things can happen with Informatica that we should be looking for. We should be looking for full table scans, because they sometimes can be problems. Index skip scans can be just as bad as a really bad table scan. So just some indexing strategies there. And there are times when indexes are skipped. And I want to jump through this real quick because I want to get to this logging. But if you look at the logging here, we need to pay attention to the read. In this particular read, we were trying to create an index here, thinking somehow this would help our plan, but it did not. What we ended up finding was it actually adding indexes caused the performance problem, and it actually doubled the execution time. So that became a problem for us, and clearly indexing in this case was not a good idea. So I want to end on looking at a few things here, kind of talking a little bit about the logs in Informatica. We have just barely a minute. Look at your target commit points. You should be looking at the logs in Informatica. If you don't look at your logs, you're missing all kinds of great information. Look for the target-based commit points, and you want to find consistent, speedy commits. You don't want long gaps between these commits. You want it to be committing consistently. You want it to be committing quickly. So those are some things we look at. Then look at your load summary. A lot of times when I pull a report, the first thing I do is scroll all the way to the bottom, and I'll look at the load summary. And I will look at the run times, and I'll look and see. In this particular case, the reader ran for 1 hour and 45 minutes. Why did it run for 1 hour and 45 minutes? Why did the transformation wait for 40 minutes, and then the reader ran again for another hour, and the transformation waited? Now, maybe that just has to be the way it is. But to me, when I look at this, I think right here is an opportunity for me to do some improvement from the source. I'm reading from a source system. I can do all those performance things. We go think back to that slide where we had all the source read performance things we could do. There's some tuning we probably could do here. Some tuning we could probably do here. Now, why it's waiting to do the transformation of the writes, I don't know. That might be an area for us to look at staging, for example. So then we go back to thinking about what are the things we should be concerned about when we're doing transformations in our staging. So, you know, using our logs to help us begin to do performance improvements, that's part and parcel of doing a health check. Really critical for us to understand how important these things are. And finally, I would be looking at the number of rows. if we consider the number of rows that we're processing, there are many times when our rows that we're processing, that we're touching, can increase and decrease over time, depending on whether we've got an incremental load or full refresh. Those are things we should be paying attention to, we should be looking at over time. So we've touched on a lot of different things, and we've gone through a lot of things very quickly, but I hope that when you think about doing Informatica health checks, that you consider that it's not just the database, that there are settings that you can do on your application. There are things you can do across networking on the SAN storage or whatever type of storage you have. There are things we should be looking at from that perspective. Really taking a comprehensive bottom-up view end to end will really give you the best output and best result. And then, how often are you doing it? And what are you doing at whatever frequency? There are things we should be doing every day, from a small, just potentially performance improvement, or just trying to find ways that we can find small incremental gains over our system, or just kind of being proactive about looking for issues to make sure that things run consistently. So I hope that you've gleaned something beneficial today, and I really appreciate you sitting in the webinar, and I hope that you've enjoyed it.
Chuck, we really appreciate you taking the time to share your expertise with everyone. And thank you to all of our attendees. If you have any questions about Datavail and our Informatica health checks, assessments, development, or operational support services, please visit Datavail at www.datavail.com or contact us at 866-583-3788. We look forward to helping you manage your data so you can manage your business.